Okay, so we are looking at what to do when we have matched pairs data today. Matched pairs, that's been a long time since we talked about that. Do you remember what matched pairs data was? No. So basically, it's data that is paired together in some way. So it might be, I want to see how effective my teaching is, so I give you a pre-test and a post-test. So it's matched pairs because for each of you I have 2 scores that I'm looking at. It might be that I partner you up and I have you study together and then I compare the scores from the 2 people in the group. So that's paired. It wasn't necessarily the same person, but you guys were paired together, and so I got my data that way. So matched pairs, we have data from either 2 different people or 2 separate points in time, but they are paired together in some way. All right, in order to do this, we have a few requirements that have to be satisfied. Just like all of these, it has to be simple random sampling. We are going to need matched pairs data, normally distributed, with no outliers, or a large sample, so bigger than 30, and they have to be independent. Okay, we are testing the mean today. When we were looking at the requirements yesterday and in the last unit, anytime we were talking about the sample mean, our criteria was either normally distributed or n bigger than 30. So that's the same here. These other things we're just kind of assuming are true, simple random sampling, independent, we are just going to assume that. So when I ask you to check the criteria, we're talking about sample mean, so it's the same as what you were doing yesterday. Sample mean, that means I either have to tell you it's normal or our sample has to be greater than or equal to 30. So no new criteria, same thing we've always done. We're doing hypothesis testing. So we still have the 3 options, left-tailed, right-tailed, or two-tailed. With all of them, your null hypothesis is equal to 0. The alternative would be greater than, less than, or not equal to 0. We're still talking about the mean, so my parameter is still mu. But you'll see a little subscript here. It's mu sub d. Okay, that is going to represent the difference between 2 sets of data. So what we're actually going to do is take our 2 sets, so your pre-test and your post-test, and we're going to subtract those, and that would be our difference. And then we're going to do the same hypothesis testing that we did before for the mean of that difference group. Okay, so once we subtract them, then we're ignoring the original data and we're doing everything that we were just doing in chapter 10 from that new difference data. So it's actually not very different from what we were doing before. We'll still have to then have our alpha level, and then we have all of these same approaches as before, classical, p-value, and calculator, and all of that stuff is the same. You'll notice, if you're looking on here or on your formula sheet, it kind of sets things up a little bit differently. I put your test statistic. This looks different than what we've done before, but we always do. It's really just finding a z-value. So, right, it's your score minus the mean divided by the standard deviation. Well, when we're looking at these, the mean in our null hypothesis is always what? 0. So that's why I just have d bar. That's just the mean of our sample, because then minus the mean of our total thing is just 0, and this just represents standard deviation. So it's not anything new. Okay, the test statistic, I wanted to show you this because if you look at your formula sheet, it looks like something new, but that's why I haven't really been using the formula sheet. I've been trying to relate it back to what we're doing. We're really just calculating a z-score. Since our variable is the mean, we're looking at the t-value. Okay. With these, we will primarily use our calculator because we will oftentimes just be given the original data, and so we're going to use our calculator anyway to get the mean and standard deviation. So if we've already entered it in the calculator, we might as well run the test from the calculator. It wouldn't make much sense to use the calculator to get all the information and then turn around and do it by hand. So let's look at an example. Alright, the following data represents the cost of a one-night stay in Hampton Inn Hotels and La Quinta Inn Hotels for a random sample of 10 cities. Test the claim that Hampton Inn Hotels are priced differently than La Quinta Hotels at the alpha equals 0.05 level of significance. Alright, so first of all, what do we need to do? We have to put this in our calculator. If we're going to do any kind of testing, we need to make sure that our criteria is met. We need a null and alternative hypothesis. So those are the places where we start. If you want to enter this in your calculator first, that'd be great. You're going to put the Hampton in L1 and the La Quinta in L2. A couple things I failed to tell you. Is my sample big enough to assume it's normal? No, so I should have told you in the problem. So I'm going to add that in. Assume it's normally distributed. Okay, so my null hypothesis is assuming that there is no difference between these things. So that would be that the mean of the difference is equal to 0. And with this matched pairs, that will always be the case. It'll always be the difference equal to 0. You're assuming there is no difference to start with. My alternative, I want to know if they are priced differently. So what would that be? No, 0. Okay, but the key here, we're talking about the difference. So what do I need to do? Subtract. Okay, so here's our options. We can go through and for each one of these, 129 minus 105 and enter that in L3 and do that for every single one of our data points, which is just subtraction. It's not hard. Could be a little time consuming depending on your values, but it's doable. The other option, I want you to go up on top of L3. So have L3 highlighted. You'll notice at the bottom it says L3 equals. Every time we're going to set this up the same. We want it to be the first minus the second. So if you hit second and the number 1, then that brings up L1 minus, we hit second, number 2, that's L2. So we're saying list 3 is L1 minus L2. Oh. And then if you hit enter, it automatically subtracts all of them for you. All right, it is important that we're all doing this the same, that it's the first minus the second, because otherwise when we start having, it won't matter on a not equal to, but a less than or greater than, if you switch those things around, it's going to get really confusing in a hurry. Okay, so we all need to agree to always do the first minus the second when we do our difference. All right, so far so good? So now we are no longer concerned with L1 and L2. We want to do our test on L3. So I want to talk about all the ways of doing this. Since it's already in our calculator, we'll probably ultimately use the calculator here. When we're talking about the means, what test do we do? T-test. So we go to stat, tests, number 2, t-test. Okay, we want to base it off data or stats? Data. If you wanted stats, you would have to go to the calculate and get it to calculate everything for you. But since we already have our stuff entered in our list, we can just do data. Mu sub 0, what is the mean of the null hypothesis?
0.
Okay, list. What list do I want to test? L3. So if you hit second and the number 3, that changes that to L3. Frequency is 1. We are testing not equal to. And then we go to calculate. And we have what we need. So what I ask, if you are doing this on your calculator, please write down your T was 5.27. Is that what you guys got?
Yes.
Okay. and our probability was, notice this has E -4 at the end. So what does that mean? Yeah, move decimal back 4 places. So it's like 0.30513. Okay. And then we know that when do we reject? So is our P less than alpha? So that tells us reject the null hypothesis. If I asked you to write a sentence, what is my conclusion here? We rejected, so there is. There is sufficient evidence to conclude. What was my null or my alternative hypothesis? Right, so just to conclude they are priced differently. We didn't test if one was more expensive than the other or which one was more expensive. We just tested if they were different. Questions right there. So ultimately, this is the exact same thing that we were doing before. Can I add in an example that I didn't have on here? I want you to open up your book to page 543. Look at problem 3. Okay, so this one tells us in the directions that we can assume they are normally distributed, so we don't have to check any criteria. It gives us a table with our x and our y, and part A asks us to determine D equals x minus y for each pair of data. So what should we do? You could go through and subtract each one by yourself, but there's really no need. So if we go to our calculator, clear out everything that's there. And enter your x's in L1 and your y's in L2. All right, and then how can I quickly get the difference? You go up to list 3, and you, while you're on top of it, you do L1 minus L2. So if I gave you this problem on homework, I am asking for the actual differences. So I would appreciate if you would just jot these down. You could redraw the whole table if you wanted, or you could just go through and tell me, you know, the first one was, what, negative 0.5, second one was 1, third one, negative 3.3. what was the next one? Negative 2.4. Okay. So if I asked you for the differences, you can use your calculator to get them and then just write down the numbers you got. Part B asks us to compute what's D bar mean? The mean of the difference, and S sub D is standard deviation of the difference. So I don't want to do that by hand. I already have it in my calculator. We go to Stat, Calculate, One Variable Statistics. But what list do I need that for? L3. So change that to L3. So D bar, that's just the mean of the difference. So that's my negative 1.614. My standard deviation of the difference was 1.915. Did everybody get that? Yeah, go to calculate and then change that to L3.
Why is the calculator that doesn't have that? Oh, I forgot what you told me.
I just hit L2 before you. Yeah, that should be that just be like what? It was already there. Maybe L1. Okay, now I got it.
What you guys put for frequency, Lindsay?
No, it should be blank.
So just like clear that out.
So that's what you're supposed to match. But that's how you would do it.
Would I do after first or no?
After.
You're welcome.
All right, did everybody get that? Okay, so then part C says test if mu sub D is less than 0. So our null hypothesis is that the mean of the difference is 0, always. The alternative, we are testing if it's less than 0. So which one am I testing if it's bigger? Which one would be bigger if the mean was negative?
That's one.
Right, so we did the first minus the second. So if we got a negative when we did that, that means the first one is smaller. So sometimes I might just say in the problem, test if the original data was greater than the new data. So then you have to think, okay, if the original data is bigger, then would my difference be greater than 0 or less than 0? Greater than 0. If I want to test if the second one is higher, then that would mean my difference is less than 0. So sometimes you have to think about that in your alternative hypothesis. This time I just gave it to you. Okay, at the alpha equals 0.05. So we can do this on our calculator. We could do it by hand. We know if we're doing it by hand, we have to calculate our t statistic, which is just our difference, which is our sample mean minus the mean of the difference divided by the standard deviation of our sample. So if I did that, oh, hold on. Then you could get your, but what am I missing on this? What do I need to do to my standard deviation? Divided by the square root of n, right? Because when we wrote down the standard deviation for the sample, not the population. So if you were to do this by hand, you would have to have the standard deviation for the whole population, which is that divided by the square root of n. What's my n here? 7. And number 3, we only put in 7 points.
I meant like all together, but that doesn't have either because it's 14.
Yeah. You test how many pairs of data when we ask about n. So that would give us a standard deviation of 0.7238. So I'll just put that in here. Now this is just showing you how to do it by hand. Is this necessary if all my data is already in my calculator? No, I'm just trying to show you that this is the same thing that we've been doing. So on these problems, I am not going to ever say you have to do this one by hand because it's just silly since it's already in the calculator to start with. But you would get your t value, and then we know we would have to look at our degrees of freedom and find as close to this as we could in our table. So, best guess from our table, we have to look for the positive. So that would be somewhere between 0.05 and 0.025, right? So we're comparing it to the alpha equals 0.05 level. So would we reject or fail to reject? We know our probability is like approximately 0.025, so we would reject. Let's check it on our calculator. So we would go to stat, tests, number 2, the t-test. We're basing it off the data. The mean is still 0. My list is still L3. We are testing less than. Calculate. And so we notice the t is negative 2.23, which we know where that comes from. We got the same thing. Our probability is 0.0336, which is just more accurate than we can get by hand. So that is less than my alpha, so we reject. Okay, so I wanted to do one by hand just to kind of show you what we're doing here, but homework, you can do them on the calculator. I'm not going to do part D yet because I'm going to talk about that in just a second. We're going to do it on another example. Are we all okay with what we would have to do here? We've also tested our hypotheses by using confidence intervals. So that is still an option. So let's talk about the confidence interval approach here. So we know we get upper and lower bounds. This formula, it looks kind of different than what we've done before, but it's really not. It is on our formula sheet, but if we want to look back to chapter 9, when we did confidence intervals, it's really the second bullet there. X bar is the mean of our sample, which in this case is the mean of the difference that we're looking at, plus or minus the t alpha over 2, and this just our standard deviation divided by the square root of n. So we could easily calculate that by hand or on the calculator if we needed to. So let's do one, and I'll do it both ways. I'll show you both options, just because it's a good review to do some by hand. So construct a 90% confidence interval for the mean difference in the price of the Hampton Inn versus the La Quinta hotel rooms. All right. Perhaps I should have done this before I had you clear all your data out of your calculator. Sorry, I got caught up in the moment and wanted to show you how to do one by hand. Why don't you go back and enter that data from the hotels back in your L1 and L2. Are you saying you didn't do the last example bit? So, quick option. If we wanted a confidence interval, we can do it on our calculator. Our variable is the mean, so we're looking at a t. So we go to stat, tests, and we want number 8, the t interval. Okay, we're going to base it off data. Your list should be L3 because we want it based off that difference. Our confidence level, what did I say, 0.90. Okay. And calculate.
Where'd you go first?
Stat test number 8, the t interval. get 33.526 to 69.274. How does that help me with whether I accept or reject? Right. We look if the null hypothesis falls in that interval. My null hypothesis was that the difference was 0. Is that in this interval? No. So we get the same conclusion. Remember, if we want to do this by hand, we will need the information. We will need the mean, standard deviation, the n, and the t alpha over 2. So just because it's a good review, let's get that. So we would go to stat, calculate one variable statistics for L3. So the mean of my difference is 51.4. Standard deviation of our difference is 30.8336. My n was 10. The only thing the calculator doesn't tell us is the t alpha over 2. We have to figure that out on our own. So remember, how many degrees of freedom do we have? 9. So we're looking at row 9. Okay, we want a 90% confidence interval. That means there's 10% on the ends. How much would be on each end then? 5%. That's if we, because we want the middle 90%. So we want to throw out the highest 5% and the lowest 5%. Okay? So we look at our 0.05 with 9 degrees of freedom. And what is your t value? So then it's just a matter of plugging that into our confidence interval formula, which is the mean plus or minus the t times the standard deviation divided by the square root of n. So if you do the minus, you get 33.527, and then we do the plus, and I get 69.273. It's just slightly different than the one our calculator gave us. The third decimal is different. That's just rounding error, and it's to be expected. Okay, so we can do confidence intervals by hand or on the calculator. Is that all right for everybody? Okay. How are we feeling? Do we need more examples? Here, I just want you guys to try one on your own. You're not going to do a full problem. I want you to turn to page 544 for me. And I want to look at number 9, part C. I want you to write down your null and your alternative hypotheses, and then use your calculator to decide if you would reject or not. So you've got a couple minutes, I'll give you a couple minutes to try that. So you put the first column, the SUV damage in L1, second column is the car damage in L2. So null hypothesis is always that the mean of the difference is 0, assuming there is no difference. The alternative, I asked you if the repair cost for the car is higher. So what would my alternative be? If the car is higher and we do L1 minus L2. So we're doing SUV minus car. If the car is bigger, would that be a positive or a negative number?
Negative.
Negative. So we're testing the alternative is that the difference is less than 0. Does that make sense to everyone? That's the hardest part about these problems. So you're doing
The opposite of what it says.
L1 minus L2. Look at your labels. That's SUV minus car. And it said you're testing if the car is higher. So if this number is bigger, so you do a number minus something bigger, you get a positive or a negative. Negative. Okay. If the SUV were higher, it would be a positive number. All right, so then if you run your test, I would appreciate it if you would write down your T. So negative 2.6855, and then our probability is 0.0181. We are testing at the alpha equals 0.05, so my probability is less than alpha. So what does that tell me? Reject. So there is enough evidence to conclude that the damage to the car is more. Are we okay there? So, that is the end of this section. Here is the plan. So, you have an assignment. It really relies on the calculator, and I know we only have a few minutes right now. I am also aware that this is kind of a crazy week for some of you. There's a lot of stuff going on right now. What we're going to do is tomorrow, I am going to teach section 11.3. Monday will be a work day for both assignments. So that way you will have time to utilize a calculator if you don't have one otherwise. So I'm going to teach both and then give you one day to work on all the homework and get your questions answered.
And like Tuesday, we also review and stuff.
Yeah, Tuesday we will do just a chapter